Have you ever had that experience where you're trying to get something done, maybe with a big company, and you get passed around on the phone?
Oh, absolutely. 10 minutes of hold music, just to be told you're in the wrong department.
Exactly. Each person says, not my job, try the next person. It's frustrating for us. But in software design, that exact process, passing a request until someone can handle it.
It's a feature, not a bug.
Right. And today we're diving into the design pattern that formalizes that whole idea, the chain of responsibility pattern, or CORE for short.
It's a classic. And the concept is, pretty straightforward. You have a source that creates some kind of command, and then a series of, let's call them processing objects.
A chain of them.
A chain of them. And the key is that each object in that chain has its own logic to ask one question. Can I handle this? If it can't, it doesn't error out. It just
Passes it on.
passes it on to the next one in the line.
So why is that so important from an architecture perspective? I mean, wouldn't it just be simpler to send the request directly to the object that you know is going to handle it?
It would be simpler, sure, but only if you actually know who the receiver is ahead of time. And that's the whole point.
Okay.
Core really solves two big problems you see in more rigid designs. First, it completely avoids coupling the sender of a request to its receiver. The sender just fires it off and washes its hands of it.
It doesn't need to know who's going to catch it.
It doesn't. And second, it gives the system incredible flexibility at runtime. It means that any one of several receivers could potentially handle that request, depending on, what's happening in the system right at that moment.
And that idea, that loose coupling, that's really the gold standard in modern software, isn't it? It means your system is flexible. You can make changes without breaking everything.
That's the goal.
Speaking of creating these really clear, efficient processes, if you're looking to bring that kind of dynamic automation into your business, you need experts to guide you.
It's not always obvious where to start.
Exactly. Uncovering where intelligent agents could make the biggest impact for your business or even your personal life, that's what Embersilk does best. Check out embersilk.com for all your AI needs, from AI training to software development.
It's a great parallel, actually, because that flexibility is so foundational. If you go back to the original Gang of Four book on design pattern.
The source material.
Right. They point out that core is structurally almost identical to the decorator pattern. But the strict definition says that ideally, exactly one class in the chain should handle the request.
Just one.
In the classic definition, yes.
Yeah.
But in the real world, we see it used more flexibly. Think about event filters or logging systems where maybe several objects in the chain might do something with the request before passing it along. The pattern has adapted.
Okay, that makes sense. So let's make this really concrete. Where could someone listening right now see this pattern in action? Like on their phone or their computer?
Oh, that's easy. The implementation in Cocoa and Cocoa Touch, which are the frameworks for OS X and iOS apps, is a textbook example of chain of responsibility.
So it's built right into the operating system.
Deeply. All the objects that can handle commands, like views and windows, are called responder objects. They're all linked in a chain.
So if I tap on my phone screen, what happens? How does the chain work?
The chain follows the visual hierarchy of your screen. So the event first goes to the smallest, most specific view you touched.
Like a button.
Like a button. If that button can't, for whatever reason, handle that specific tap, it doesn't just drop it. It immediately passes the event up to its parent, its super view.
So it bubbles up.
It bubbles up the chain. From the view to maybe a view controller, then to the main window, and maybe finally all the way up to the application object itself. It's an ordered system for finding a handler.
Ah, that explains that classic Mac example. You can drag a window from almost anywhere on its surface, unless you happen to click and drag on a slider or a scroll bar. That specific control intercepts the drag first. But if you just click on a blank area, that drag event bubbles up to the window object, which knows exactly how to move itself.
A perfect and very clear example of that runtime delegation.
The chain of responsibility pattern is just. It's such an elegant way to structure delegation to handle uncertainty. It helps build systems that can sort of self-organize and react.
It really does. And that brings up a pretty interesting thought for you to take away. Since this whole pattern relies on runtime conditions to decide who handles a command, how might that kind of innate flexibility change how we design, say, completely decentralized autonomous software agents in the future? This structure allows complex systems to find solutions without any central brain telling them what to do.
That idea of autonomous problem solving, that's a really inspiring way to think about architecture. If you enjoyed this deep dive, please subscribe to the show.
Hey, leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in.